Hi, welcome back. So we are going to continue with May-June 2023 variant 4.3. So starting with question number 10, the table shows some values for y is equal to 2 to the power of x minus 3 and complete the table. We need to find the values for these three boxes here. So here, instead of x, you replace it with minus 1. So for the first one, instead of x, you replace it with minus 1, 2 to the power of minus 1, minus 3. 2 to the power of minus 1 is basically 1 by 2. So 1 by 2 minus 3. 1 by 2 is 0 0.5. 0 0.5 minus 3 will give me minus 2.5. So the value over here is minus 2.5. The next one, x is 0. Anything to the power of 0, we know the value is 1. So 2 to the power of 0 is 1. 1 minus 3, minus 2. Finally, when x is 1, so replace x with 1. 2 to the power of 1 is 2. 2 minus 3 is minus 1. If you have got these 3 points correct, then you will be getting 3 marks. So the B part, on the table, on the grid, draw the graph of y is equal to 2 to the power of x minus 3 for minus 2 less than or equal to x less than or equal to 2.5. So I just have to plot these points. So my first point, minus 2 and minus 2.75, I will come to it, but I'll better try to plot the points which are simple. So minus 1 and minus 2.5 I will start with. So minus 1 and minus 2.5. Minus 1 on the x, minus 2.5. So 2.1, 2.2, 2.3, 2.4, 2.5. So this is minus 1 and minus 2.5. This will be my first point. Then 0 comma minus 2. 0 comma minus 2, x coordinate is 0. That means my point is on the y-axis. 0 comma minus 2 is over there. And then 0.5 comma minus 1.58. I'm not going to do that because it is very difficult to plot. I just need few points. 1 and minus 1. So 1 and minus 1, I can plot this 1 on the x-axis, minus 1 on the y-axis. This will be my point. And 1.5 minus 0 minus 0.17, I ignore that because it's difficult. 2 comma 1, so I'll take 2 comma 1, 2 and 1, 2 on the x-axis, 1 on the y-axis, and 2.5 comma 2.666, I'll ignore that. If I need that, I'll come back to it later. And then I'll minus 2 and minus 2.75, so minus 2.5 is over here, 2.6, 2.7, 2.75 is somewhere over here. This is 2.75. So I have few points, and then finally I'll just take 2.5 and 2.66 approximately. So 2.5 is over here, 2.66, that means 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, close to 2.7. So I'll just take somewhere over here in the middle and close to 2.7. So on the grid, draw the graph of y is equals to, I know that this is an exponential graph. 2 to the power of x is an exponential graph. And exponential graph, we know the shape of an exponential graph. It will be something like this. When the this is 2 to the power of x. So y is equals to a to the power of x. If a is positive, greater than 0, we will be getting something like this. If a is greater than 1, actually, and if a is between 0 and 1, if a is between, that means a is greater than 0 and a is less than 1, that means in between 0 to 1, if my a value is in between 0 to 1, the graph will be the other way around. So this is how an exponential graph will look like, a to the power of x when a is less than 0. And this is an exponential graph because 2 to the power of x minus 3. Now we just have to join these points. Make sure that you are not using a ruler here. A rough hand sketch is better. So this is how our graph will look like. So 2 to the power of x minus 3, I have plotted this on the grid. Now for that it's a 4-mark question. If you have joined the points correctly, if the points are correct, then you will be getting full 4 marks. Use your graph to solve the equation 2 to the power of x minus 3 is equals to 2. So what I have here is 2 to the power of x minus 3. What I have here is 2 to the power of x minus 3, and it is clearly mentioned use your graph. So we need to use the graph. So when you have something like this is basically the point of intersection of y is equals to 2 to the power of x minus 3 and y is equals to 2 and y is equals to 2. So the answer which we are looking here is the point of intersection of these two graphs. Y is equals to 2 to the power of x minus 3. The left hand side, it's already there. And I need to plot y is equals to 2. Y is equals to 2 means it is parallel to x-axis and passing through 2. Parallel to x-axis and passing through 2. So y is equals to something means it is always parallel to x-axis. X is equals to something means it is always parallel to y-axis. So here it is y is equals to something. That means it is parallel to x-axis and it passes through 2. So parallel to x-axis and it passes through 2. So this is the line for y. This is the line for y is equals to 2. And this is the graph for y is equals to 2 to the power of x minus 3. So we need to use the graph. As I said, the point of intersection. Point of intersection is somewhere over here. So from there, you just make a line. If you can use a ruler, then that is better. So it is somewhere, I'm getting 2.1, 2.2, 2.3. In between 2.3 and 2.4, let's say 2.35. Let's say that it is 2.35. And for this, the answer will be in a range because, there can be a slight difference in drawing the curve and drawing the line. And also it may be answer will be around between 2.2 to 2.4, something like that. So now moving on to the next part here. By drawing a suitable straight line, solve the equation 2 to the power of x minus 1.5 is equals to 0. So 2 to the power of x minus 1.5 is equals to 0. If I go back and check this, the curve that I am having here is 2 to the power of x minus 3. The curve that I am having here is 2 to the power of x minus 3. I need to do something. Somehow I need to make my left hand side 2 to the power of x minus 3. Just keep this in mind. Somehow I need to make my left hand side 2 to the power of x minus 3. So what I know is I don't want this x term here. I'll take this minus x to the other side. So 2 to the power of x minus 1.5 minus x goes to the other side, it becomes positive x. So keep this in mind. We always have to make, my duty here is on the left hand side, it should be 2 to the power of x minus 3 somehow. Now I have 2 to the power of x minus 1.5. I need another minus 1.5 on the left hand side to make it 2 to the power of x minus 3. So 2 to the power of x minus 1.5 minus 1.5. But if I'm subtracting, if I'm adding a negative 1.5 on the left hand side, I need to add negative 1.5 on the right hand side as well. Now what do I have? 2 to the power of x minus 1.5 minus 1.5 is 2 to the power of x minus 3 is equals to x minus 1.5. This is what we need. If I check, my left hand side is 2 to the power of x minus 3. The answer will be, given that we need to use the graph, the answer will be the point of intersection of y is equals to 2 to the power of x minus 3 and y is equals to x minus 1.5. X minus 1.5, it is a linear graph, so it will be a straight line. We are going to use our normal traditional table method here to find out the points. So y is x minus 1.5. Take any few random points here. Let's take 0 first. When x is 0, y is equals to 0 minus 1.5, that is minus 1.5. Let's take x as 1. When x is 1, 1 minus 1.5, that is minus 0.5. When x is 2, 2 minus 1.5, 2 minus 1.5 will give me 0.5. These are we need only 3 points and then extend the line. So 0 comma minus 1.5, 0 comma minus 1.5 minus 1.5 will be somewhere over here. 1.1, 1.2, 1.3, okay, minus 0 comma minus 1.5. If you want, I can just use a different color so that it will be easy. So 0 comma minus 1.5. And then what else do we have? 1 comma minus 0.5. So 1 comma minus 0.5 will be 1 on the x-axis minus 0.5 on the y-axis. 0.1, 0.2, 0.3, 0.4, 0.5. This is minus 1 and 1 and minus 0.5. Then finally, we need 2 and 0.5. 2, 0.1, 0.2, 0.3, 0.4, 0.5. This. And then we just have to, let's take what happens when x is minus 1 also. When x is minus 1. So when x is minus 1, minus 1 minus 1.5, that will give me minus 2.5. So when x is minus 1, when x is minus 1, it will be minus 2.5. Minus 2, 2.1, 2.2, 2.3, 2.4, 2.5. So it passes through this point. So what we need to do is, we just have to use a ruler. So I don't have a ruler right now. So we just have to use a straight ruler and then join these points and then join these points. So when you join these points, it will be cutting at, there will be 2 points of intersection. One is over here and the other one is over here. From these 2 points of intersection, draw a vertical line until it touches the x-axis. So this point, it is touching the x-axis at minus 1, and here this point is touching the x-axis at, let's say, 1.5, 1.6, 1.7, something around 1.7. So let's say 1.7, this is minus 1 and 1.7. So your answer will be x is equals to minus 1 and x is equals to 1.7. Moving on to the 11th one here. M has coordinates 4, 1 and n has coordinates minus 2, minus 7. Find the length of Mn. So we know to find the length of Mn, we need to use the distance formula. So if we have x1, y1, and if we have x2, y2, then the formula, the distance formula d is equals to root of x2 minus x1, the whole square, plus y2 minus y1, the whole square. So this is basically root of, what is x2? x2 is minus 2. Already there is a negative sign, so put that negative sign. x1 is 4 square plus y2. What is my y2? Minus 7. Already there is a negative sign. Then y1 is 1. So minus 2 minus 4. Minus 2 minus 4 is minus 6. Minus 6, the whole square is 36 plus minus 7 minus 1 is minus 8. Minus 8, the whole square is 64. So this will give me root of 36 plus 64, that is 100. Root of 100 is 10. So the distance or the length of Mn is 10. Find the gradient of Mn. We know the formula to find out the gradient when 2 points are given, y2 minus y1 over x2 minus x1. y2 is minus 7. Then a negative sign is there. I am putting that negative sign. y1 is 1. Divide by x2. x2 is minus 2. Already there is a negative sign. x1 is 4. So minus 7 minus 1 is minus 8. Minus 2 minus 4 is minus 6. Both the negative signs gets cancelled. 8 over 6 can be written as 4 over 3. Both of them are coming in 2 times table. So I got the gradient as 4 by 3. Now find the equation of perpendicular bisector of Mn. Perpendicular bisector of Mn means, let's draw this line Mn. Now the point M was given as 4, 1, 4, 1 and minus 2, minus 7. N was given as minus 2, minus 7, yes. Now, you need to understand what perpendicular bisector means. Perpendicular bisector means it will be a straight line passing through the midpoint of Mn. So it will be a straight line passing through the midpoint of Mn, and it is cutting the line Mn at 90 degrees. The meeting point over here, the angle made at the meeting point will be 90 degrees. So we need to find out the equation of this line. Let's call it as L here. We need to find the equation of this line, which is perpendicular to Mn. So perpendicular to Mn, perpendicular bisector, I need to find out the midpoint. So midpoint, we know the formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is the formula for midpoint. X1 is 4, x2 is minus 2. 4 minus 2 is 2, 2 divided by 2 is 1. Y1 is 1, y2 is minus 7. 1 minus 7 is minus 6. Minus 6 divided by 2 is minus 3. So it passes through 1 comma minus 3. So equation of a line which is perpendicular to M. And we know the equation of a line is always in the form of y is equals to mx plus c. M is the gradient and c is the y-intercept. We need to find out m and c. If the lines are perpendicular, the gradient will be negative reciprocal of mn. So mn, I know the gradient is 4 by 3, 4 by 3. So negative reciprocal of 4 by 3 will be negative 3 by 4. Negative 3 by 4. So negative reciprocal of 4 by 3 means it will be negative 3 by 4. So we got the m value, negative 3 by 4. So y is equals to negative 3 by 4 x plus c. I repeat, how did I get negative 3 by 4? If the lines are perpendicular, then if we know the gradient of mn, the gradient of this line L will be negative reciprocal of mn. So negative reciprocal of 3 by 4 is 4 by 3 is 3 by 4. So minus 3 by 4 x plus c. Now we need to find out c. In order to find out c, let's take the point that it is passing through, the midpoint. Midpoint is 1 comma minus 3. Substitute for x as 1 and y as minus 3. So y is equals to minus 3 by 4 x plus c. X is 1, y is minus 3. Y is minus 3. Minus 3 by 4, x will notice it is 1. So plus c. Minus 3 by 4 goes to the other side. It becomes positive 3 by 4. So minus 3 plus 3 by 4. Two fractions and in between a positive sign. To get the denominator, multiply both the denominators. 1 and 4, when you multiply, you will get 4. To get the numerator, cross multiply. Minus 3 into 4 is minus 12. Plus 3 into 1 is 3. So minus 12 plus 3 is minus 9 by 4. This is my C and this is my M. So final answer, y is equals to mx plus c. M is minus 3 by 4 x plus c. C is minus 9 by 4. Minus 9 by 4. This will be your final answer for the equation perpendicular bisector of Mn. Perpendicular bisector of Mn, you need to know that it passes through the midpoint of Mn. First, you find out the midpoint of Mn using this formula. And then we know y is equals to mx plus c. Mn, the gradient of Mn, we know it is 4 by 3. So perpendicular bisector will be negative reciprocal, minus 3 by 4. And then substitute the midpoint in y is equals to mx plus c. You have m, x and y. You substitute the midpoints, you will get the c value. You have m and c, substitute in the standard form, y is equals to mx plus c. The last question of this paper, the equation of a curve is given as y is equals to x to the power of 4 minus 8x square plus 5. Find the derivative dy by dx. So dy by dx will be x to the power of 4. We know the derivative is 4x cube minus 8x square. The derivative, we know it is 16x. Derivative of a constant is 0. Now, find the derivative. 2 marks, you already have. Find the coordinates of the 3 turning points. To find out the turning points, we take dy by dx and equate it to 0. So 4x cube, basically 4x cube minus 16x, we need to equate it to 0. 4x cube and 16x, what is common there? 4 is common and x is common. Now what else is remaining? 4x multiplied by x square will give me 4x cube minus 4x into what will give me 16x? 4x into 4. Now 4x into, this can be written as x square minus 2 square. Now we know the formula for x square minus y square, that is x plus y into x minus y. What we have here is x square minus 2 square. Wherever we have y, we replace it with 2. So x plus 2 into x minus 2. So this will become 4x into x plus 2 into x minus 2 is equals to 0. Now we need to equate all three of them separately to 0. So 4x is equal to 0, x is equal to 0 divided by 4, 0. Now x plus 2 is equal to 0, therefore x is equal to minus 2. And x minus 2 is equal to 0, therefore x is equal to 2. We got all the three turning points x values. So x values are 0, 2, and minus 2. Now we need the y values. For y values, go to the original equation. What is the original equation? Y is equals to x to the power of 4. Y is equals to x to the power of 4 minus 8x square plus 5. Y is equals to x to the power of 4 minus 8x square plus 5. Now substitute when x is equals to 0. What will be my y value? 0 to the power of anything is 0, minus 8 into 0 is 0, plus 5. So y is 5. When x is 0, y is 5. Now what happens when x is equals to 2? 2 to the power of 4 is 16, minus 8 into 2 square is 4, plus 5. 16 minus 32 plus 5. 16 minus 32 is minus 16 plus 5. That will give me minus 11. So when x is 2, y is minus 11. So now when x is equals to minus 2, minus 2 to the power of 4 is 16. Minus 8 into minus 2 to the power of 2 is 4 plus 5. Same thing as the previous. So 16 minus 32 plus 5, which is 16 minus 32 is minus 16. Minus 16 plus 5 is minus 11. So minus 2 and minus 11. We got the answer for the B part. Finally, the C part. Determine which one of these turning points is a maximum. To find out the turning point is maximum, what we need to do is d square y by dx square. If it is greater than 0, then we know it is minimum point. And d square y by dx square, if it is less than 0, we know it is maxima. So let's first find out what d square y by dx square is. Dy by dx was 4x cube minus 16x. So dy by dx was 4x cube minus 16x. Find the derivative of this, that will give us d square y by dx square. 4x cube derivative will be 12x square minus 16x, the derivative will be 16. So 12x square minus 16. Now take each point and see when x is 0, 5. When x is 0, 5, just substitute x with 0 here. 12 into 0 square is 0 minus 16. So this is minus 16. So d square y by dx square, I'm getting a negative value. D square y by dx square, if it is a negative value, this is a maximum. So 0, 5 is a maximum point. Now let's take d square y by dx square. We got it as 12x square minus 16. Let's take the next point, 2, minus 11. 2, minus 11. So when x is 2, 12 into 2 square, that is 12 into 4. 12 into 4 is 48 minus 16. 48 minus 16 is 28, isn't it? 32, 48 minus 16, sorry, that is 32. So 32 is greater than 0, d square y by dx square. If it is greater than 0, this is a minimum point. Finally, we need to check for minus 2 and minus 11. So d square y by dx square, we know it is 12x square minus 16 and minus 2 comma minus 11. X is minus 2. So 12 into minus 2 the whole square is 4. So 12 into 4 is 48. 48 minus 16 is again 32, which is greater than 0. D square y by dx square, if it is greater than 0, this is also a minimum point. In the question, they're asking us to find out what is the maximum point. So the maximum point here is 0, 5. The remaining 2 points, minus 2, minus 11. When I find out d square y by dx square, I'm getting greater than 0. That means it is a minimum. And so for 2 and minus 11 also, when I found d square y by dx square, I'm getting a value greater than 0. That means it is a minimum point. So that's it. We are done with May-June 2023 variant 4.3. In the next video, I'll be doing maybe variant 4.2. So I hope you have understood the concept. If you have any doubt, feel free to write it in the comment box. Thank you for watching.